Good morning, everyone. My name is Henno. Today is another SV Academy day. Hopefully somebody can throw the thumbs up that my voice is coming through. And in a line that Academy is the number 15. So it's time goes fast. What is today's subject? Today we're having thermal insulation fixing. And I fly through quick our part of the introduction. So we have more time for our external speaker, Markus Waldner-Novak. And here we go. We, as SV, shortly represented in a Nordic area in 1,100 different locations. We have 7 offices around in Europe, and we belong to the Bergman & Beving group. Who doesn't know that? Then this is a very short and light introduction. What I wanted to say that those are our 4 core focus areas, and today we are able to put together that green circle here, where we talk about roofs and facades, which is kind of building envelope, and then it's a frame installation system. So this is the subject where we dive in from our mix of product range. We actually go deeply in only on that insulated wall or roof area. And we have here today Dr. Professor Waldner-Novak. He's also background in guest professor, University of Oxford, FH professor itself in Joannum. And his specialty is fire, timber construction, and timber connections. But myself, I'm Enno, located in Estonia, supporting Baltic States, Eastern Europe technical sales. Reminding that we have our own S-Wood, which we lightly developing forward. And you will find my contacts here if you wanted to ask any questions after Academy or in any other time. Subject shortly. When you have some kind of timber frame wall, then in a frame wall, it's option to put full insulation on the top on the first step. Normally you build that up with the brackets or a cross patent framework, but today's subject is you can have a full insulation on it. Then normally you're going to have their wind barrier, which makes this application internal. And this application, we are looking in 50 years working lifetime. And I have put here some recommended environmental classes to the wooden joints as well. Now we're coming with the framework. And the framework normally we fix with first 2 screws or 3 screws, or to get it leveled, but also cross-fixing. So we get nicely frame fixed. And according to the calculation tool, we do the distances here. In next step, you need kind of angle fasteners, which takes all the vertical loads. So that's also according to the calculation tool we're gonna introduce you later, and then it comes on facade. So this is pretty much that subject Markus will dive in. He is our support person and developer of our light so-called software. I will remark that in SV range we have very known ETT screw, which is a double-threaded screw. And I have marked it red in reason that the double-threaded screw ETT is not recommended to use for this application, because here the second thread have a different geometry and having a traction effect, which means pulls elements together. And when you fix it, it's have a difficulty to install and level the facade framework on it. So for that, we have another fasteners. Either one you're gonna use full threaded screw from SV range, or we have also double threaded, but it's same geometry, called CYDT. So this is kind of light intro from my side, just as a picture that this product have also ETA approval, and it is approved for roof and facade, having a C marking on that. Here on right hand side, you see typical facade elements where you build that up. I have background on brick, but it could be a cross-fixing of different timber application, or it could be a wooden wall with having a ethics type of solution and you want to renovate it. So for that reason, you can do it like a CLT new buildings or renovation if it's a timber behind it. We have 4 key arguments. Insulation is roof facade areas. So cross frame is not needed, so you can replace with screws. Good thermal insulation up to 400 millimeters. And thermal insulation is kind of wide usage area. So if you have more questions, in Eastern Europe, we develop also further on timber to concrete application. But that's not today's subject, the timber to concrete. Today is more timber to timber. But here we go. We have a Markus. You will get the overview of description. He's mild timber construction software developer and the leading research projects on topics of fire protection, timber construction, and timber connector. Markus, here is your presentation, and you can take your screen sharing. You're welcome.
Yes, fine. Thank you for the introduction, Eino. And I'm happy to be here today. And I am an engineer, as Eino said, and my main topic is timber. And I have some experience in the design of timber design tools for engineers and also for carpenters. And Eino and I, we developed a tool for designing facades and roofs and the insulation systems there. And in Austria and Central Southern Europe, we find this a lot for the roof refurbishments. And so this, I think, is an interesting application for the future as well. So I will share my screen. And what I want to do is give you a short overview over the systems there and a little bit about the technical backgrounds, and then dive in to two examples. One, the facade and one for the roof. It's just very brief. It's always, if you show a design tool, you can just show a little bit, and then if you're an engineer and you have to deal with, you have to think and consider a little bit more. It always looks very easy when you show it, but that's in the nature of this. So I start with the roof because that was the last slide we saw, and there we have two different ways to either newly install and very often to refurbish and to thermal insulate later. And the one is with the so-called hard insulation. It's an more or less incompressible insulation. And the screws there hold the roof structure that is built up against sliding down on the one hand, so they are inclined. And there is we will see another slide, a mechanism that screws goes in tension and the insulation can catch the compression part, which is not very much, but it can transform it. And on the other hand, we have a few screws that are responsible for the wind suction. So we have some screws for wind suction, against wind suction if it's required. Depends on the weight of the cover, and the other screws. And then there is a second system where you can use soft insulation. There it's more like a stilting system. So the insulation just insulates and doesn't carry any compressive loads or something. So you keep a distance. It could be a void as well, but you want to use this space for the insulation, it's clear. So these screws are in compression and tension. And depending on the loads, you transfer the loads through the screws, and that keeps the distance. And there's often a question, what's the difference between so-called hard and soft? It's not a very exact term, we know. But the difference is with the strength or the stress that you can apply till the strain is 10%. So, and that's 0.05 Newton per square millimeters. And if you calculate it, I did that. It's easier to understand for me or to memorize. If you step on this insulation, you have about 250 square centimeters on 1 foot at the bottom of your foot, and a little bit more heavy person would produce this stress. So if you step on it and it compresses more than 10%, it's probably a soft insulation, and if it's stable, it doesn't compress much more than it's considered a hard insulation. And the producers usually define this, and we have our different products in the software as well. And then there was a little bit of work to do with the modeling and with what can break. You know, that's the engineer's job. Murphy's law says that everything that can go wrong will go wrong, and we want to avoid this. So that's our way of thinking. So we think about all the different mechanisms that can lead to damage to prove that they won't. And this it's a bit mixed in language. I hope you, but I added the translation so it's understandable. So we have all different failure modes from the screw and the wind suction. So we have shear from the roof, and then different failure modes, and the software checks all these modes. And we have different loadings. It's snow, wind, and self-weight usually that are considered here in the software. A little bit more difficult in terms of statics is this stilt solution. Because then you have to find some structural systems. The counter batten works as a light beam on top, and then the stilts are like supports, like in this diagram here. And you can find some moment lines and can solve this. That's not so much of a problem, but that's a bit beyond the European technical approval that SV has, and that's implemented in the software. So the roofs are a little bit more complicated in terms of structural models. So this we solved first, and then we continued with the application in a facade. And I will, in terms of examples, then start with the facade system that Enno just also showed. And usually we have one screw vertical and one inclined, and you can set as ever you want. We could also tilt both screws. You can define these angles here, the top screw and the first screw and the second screw can have its angles. In the roof, it's usually 60 degrees, like we saw here. So they're both inclined, and in the wall, as Enno also said, usually you set the distance first, and then you screw the additional lifting screws for the vertical load. And here you only have self-weight usually as load clear. The screws have to carry the additional structures here, and you have wind compression or wind suction. That's the thing here. There's no snow load or something is clear. Yes, so this is about the main structural thinking behind the programs we have. And I want to show you two examples just to see how the program works and give you some hints how you can apply and use this. So we have one with a rather thick insulation of 320 millimeters, soft insulation. So this is compressible, and the screws have to take all the load. There will be no help, so to speak, from the insulation, no load carrying help. And then we have no loads, no other than the self-weight and the wind. And I used the counterbatten rather thick then because the screws need to have a certain amount of thread in the counterbatten, so you have to have a bit of a section there. And the substructure is not really important. I chose 20 centimeters. It could be less. In CLT, it's sometimes only 12 centimeters. That can depend from case to case. And then, as I said, the screw angles will be 90 degrees for the first screw and 75 degrees, so it's inclined for the second screw. And then we start with a second example for a roof. So to come to the, I just changed the screen. It's easier for me then. So to come to the example, we have this software. Enno, you have to tell me where to download it, or to tell our guests where to download it. I think you know.
Yeah, we will upload that in our website, and after the academy latest tomorrow, okay. I will respond everyone to get it the right area to find it.
Good. Okay. So you open this, and it's a solution that works within Microsoft Excel. So this is a requirement that you have Excel installed. And sometimes you have to set, that depends on your computer, but sometimes you have to set that you trust this file. You have to...
It's asked to open in macros, yes.
Yes, it uses macros, and sometimes these are blocked, and there's, in the trust center, you can say this directory or this file is trustworthy, and then it works. Otherwise, there would be an information screen that the macros are not active. And then the structure is relatively straightforward. You could set data from your site location. That's more for the roofs than for the facades. I will use that for the roof more than for the facade. So because we want to have the snow and the wind load, we could do this also. Maybe let's do this also here for the facade, because we want to know about the wind. So we could just set some values here. So we want to input some data here from Estonia, Tallinn, for example. The geometry will be set later, and then the snow load is not really interesting, as I said here, for the facade system, but we could say we are in terrain category 2, and our basic wind is maybe
21 in Estonia. Yeah,
1
you're right.
meter per second, right? So then we get this peak velocity depending also on the height, the ridge height, which we will set later. So it could change a bit, but we preset the place and inform the program how wind will be. By the way, if there are questions, it would be great to write into the chat. Then we come back to you with the questions. Okay, so we also have these wind values here, and then we go to the second sheet, which is the thermal insulation itself, and then we have output. It's always a summary and a calculation. So the summary is the short output, and the calculation is the longer output. And in this case, we have a soft insulation. As I stated, we want to have this system with the stilts. The screws are stilting the counterbatten, so to speak. And we've set here the load for snow and also the live load to 0, because we don't need any live load here. And we can set a facade weight from the additional build-ups. That's usually rather lightweight. It's only 0.2 or 0.3 kilonewtons per square meter that comes from the loading. And then here we have 90 degrees. So this is a universal tool. You can use it for the roof and also for the facade structures, for the walls. And we can have a batten spacing maybe of a spacing of 0.625 meters. That's sometimes or often used, and the height could be maybe 6 meters. And also the wind is calculated then for the 6 meters. And then we have the counterbatten dimension and also the quality. Usually it's a C24, and I used 8 times 6. I will give you the information later. We can see if we reduce what will happen then. So I have a rather large counterbatten. And then we said we have 320 millimeters of insulation. And the batten dimension could be, I don't know, 10, 20, or if it's a CLT, it could be 100 centimeters. It's like a 1 meter stripe. That doesn't really matter. The width is not so important. It's just some information for the program to deal with the screws also. And then we can set which screw we want. By default, it's the shortest screw is selected, which is seldomly correct. And you get the information. First, here there's a block about the geometry of the screw, and the program checks all the length values and also the thread length in the counterbatten and so on. So we get for the input, we get an information here about the length that is geometrically feasible. So it should be longer than 470 millimeters with the 60 degrees. And we have to change this. First, we want to set this to 75 and 90 degrees because we have this system and the length change a bit. And we can set this now by hand. Either 450 is too short, 500 would be good. So if you take a 500 millimeter long screw, the program there's nothing red here. The screw 2 and the screw 1, they have both the correct length. And the only thing now we have to set the screw distance, or we could say optimize. So then the program looks for the screw that's geometrically feasible and also changes the screw distance. So every 45 minutes, that's the result the program finds. And we have to scroll up. So every 45 minutes, it repeats. So the actual distance is 45, and between the two screws, it's 5 centimeters. That's usually a default. You can change this also. That doesn't change much. And then as a result, you get the number of screws. You get 540 screws in this case for the whole area. And in the summary, you can see how many screws per batten or how many screws per square meter wall you have, so that you can calculate and estimate the price for the screw for the screws in the project. And this is only a one-sheet information, which gives you the most of the required information. And if you want to see the details, you have all the calculations here that with the models and also the screw design of this installation. And then when you finished, you can go and print. This is a German version now, but sorry. But it should work also in your language, in your Excel language. And if you press print, then you have the option to select or deselect parts. You could just print the summary if you want, or you just print the location and the calculation, whatever you want. So you can choose between the sheets that we have. And the result then is a PDF file that looks like this. So you get here the information about the facade. We didn't fill out in the moment for this example the data, the required input, and you get all the data you need for the design and also for the producers, so to speak, or for the end
installers.
For installers, that's the word. Thank you. And the other thing we could do is, that's just a very brief look. We could set here a roof structure. Then we could maybe try with a hard compressible, incompressible construction, and maybe have a 30 degrees inclination. And the screws then are the inclined has 60 degrees, and the other one is vertical for the wind suction. And maybe here the insulation thickness is less than we had before. It's maybe 20 centimeters is 200 millimeters, and then we can. I think that's what I wanted. And then I can here also press and optimize, and then the program tells me how many or what size of screws is feasible. Usually it's the narrowest and the shortest possible that's suggested. So you can choose this one, and the program then also checks the geometry. That's the first thing, and then also checks calculates the number of screws. In this case, that's something we need to set. I have to reset here. These round buttons are to reset the values. I set this node to 0 because it was a facade. You remember. Now I reset to the default snow load from the location we had. Now the values will change a bit. Yeah, it's 66% load bearing capacity of the screws, which is quite a reasonable value. And for the wind suction, we can set a maximum distance because sometimes the values are very low, and usually you want to have a certain amount of screws, each rafter at least 2 against the wind suction. Yes, and that's another option to use this program for the single pitched or for the double pitched roofs. Okay, and that's my part. I just gave a short introduction, and I had 20 minutes. That's what we appointed, so I don't want to overstress time. And thank you for listening. And I'm looking forward to have some questions if there are.
Yes, there are questions, and let's start quick on the questions. We have Olex who have asked that, is that possible also to calculate for single screw instead of pair of screws?
For single screw, I mean, you could do something. You could set the values, the angle identical. So for if you have soft insulation, I have to reshare. I don't have to share. You can take them parallel, and then you calculate 2 screws, but they are parallel, and it's like a single screw then.
But sorry, but will that work if you both have a wind load and a snow load, or like because aren't they supposed to take the load, different loads, like the different angled screws are
yes, yeah,
different loads, so to say.
So the soft the tool for the soft screws that calculates the screws individually, and they take wind and other loads, weight loads and snow loads. And if you choose the hard one, then it always depends. That's not possible to calculate without, because then there is only one screw that takes the shear from the roof together with the compression of the insulation. And the wind load is transferred using the suction screws. Sometimes it's very low, the wind suction, and you don't need many. You only apply 1 or 2 per. I would always use 2 for each rafter, and that's all you need. So the hard insulation modules, they actually have only 1 screw for the shear loads, and if you want to have only 1 direction of screws, you could use module B with the same angle. And we are working on a module that calculates an individual screw, if this is a question. So if you want to calculate just the tension or the force that the screw can transfer from one part of the structure to the other, then we have a simple module in work in progress, Enno and I, that you can simply use this. So the module that I showed today is more the system approach, and we have a very basic one that's coming also.
Thank you. I have another question from Olex, and before I go for the question, I will also release 1 poll for you, everyone, and then I will raise the question. The first poll is about thermal insulation itself, how relevant it was for you, and here is multiple answers possible, so you feel free to answer that. And looking forward to your feedback. But what was a question from Oleg's side is that is it available in multiple languages? Just a quick feedback is that we have it in English. He have written that has issue when macros were written by Danish. He have experience in general, and it worked in properly because Windows main language was Latvian. And maybe shortly answer Oleg's that when I send you the link now after the Academy, test it. And if you have a problem, we will come back to you to support and find a way so that it will work in your computer. Yes. That's maybe, then we have one more question here, I think.
Yeah, and we prepared it and we tested it also. So usually German and English works well. And we also prepared some other languages which might fall back to English on some terms. But we tested this and also on English and Latvian computers. So this shouldn't be a problem. It's considered maybe this in addition to, you know.
Then Michael is asking, if I use soft insulation, then is there a chance that the insulation deforms and I have to check the screw for compression stability?
Yes. No, it's the program checks the screws for compression. And that's I didn't really show it in detail, but the screwing compression is always weaker than in tension. As we know, it's always a buckling topic then. And it's just this free length between the counter button and the rafter is like a clamped beam part or a column, and it's calculated. There is in the European technical approval, there is a design for this, and it's calculated. So the program checks which screw gets tension and which screw gets compression, and then designs this also. So compression is always covered.
First, Paul, feedback. Yeah, go ahead.
Can I just, it takes long to write. So is it usually just cheaper to use harder insulation so I wouldn't have to check the compression? Because compression is, yeah, I would have to use so many more screws, I think.
Yeah, Michael, I think you're right. In general, the compressive or the hard insulation is easier and leads to less screws. It's also a little bit easier to install because you can step on it and so on. And the pairing of screw together with compression of the insulation is more optimal.
Can I squeeze in a question also?
Go ahead. Go ahead.
In the if you do it on the facade application, can you then also get the displacement of the counter batten, like the vertical displacement of the counter batten? Is that calculated?
You get the moment, not the displacement really. Let's see. No, I don't calculate you get the compression force, and there is a model for as a beam that's continuously supported for the counter batten, but the displacements are not calculated. It's more the
because maybe that's something that could be added, because if you have displacements of like high displacements of 10 millimeters, then that's maybe not.
Yeah. I mean, that's a good point. We calculate here. If you see this is the part of the counter batten, and you can see here the compression and the model for the moment, and there's almost everything here. So you have the young modulus and the thickness and the bedding width. So you actually there's not much missing to estimate. It's not so easy to calculate the exact value, as you know, but you can estimate.
But not in this direction. But rather, if you use it for the facade, you would want displacement in the.
Okay, the vertical.
In this way, it would be in the horizontal.
Direction. That you mean? Okay. Yeah, you mean that coming from the tension of the screw a bit. I mean, usually that is not much. It's relatively stiff. Yeah, yeah. We could calculate this one. Yeah, yeah. We could do that. Mm-hmm. Might be interesting.
Coming back to the previous poll, 40% happy to use, 26 more focused to facade, few on roof, and some of them didn't feel relevant. I have actually another poll as well, and a quick asking here, and then I will probably raise another question to Markus. So this is a little bit related. What application area are you looking forward to use it in your next project? And you can also give here a multiple answer if you will have it. So happy to hear your feedback. What I had as a question is how to deal with a thin counterpattern, because in Eastern Europe often the counterpattern is very thin.
Yes.
What they use. So what is the solution then?
Yeah, then we have, there's one thing, I share the screen again. There's a rule in the technical approval that at least a certain amount of thread should be in the counterpattern. And we had this also in a project in France once. With quite a thin counterpattern, so you could adjust the screw. That's more a bit a topic for the installers to actually keep the head a little bit out. So you could either choose another screw, or you choose a screw and leave the head a bit out. And you can set this here with, you can have a sunken head, you can have the head outside, or so you can set it also to this thread start. So it's for this selection screw here. In this case, it was 20 millimeters from the, because it's a cylinder head, from the very top of the screw till the thread starts. And if we lift it up a bit, then we can have thinner counterpattens as well. So we could have 4 centimeters as well. Yeah, now the screw might be too short, but the length in the, so we should, okay. We have to have the 300. So then the thread is longer in the substructure. And if you have now it's only, I don't know if it's only, let's 3 centimeters, it says it's not recommended in the European technical approval. You can still decide, I still want to calculate it. And if I leave 4 and set this to 0 and say the screw is 0, yeah, in this case it still works, but that's an option you can deal with. So if it's only a question of millimeters, you can set the position of the screw in detail.
Thank you. And as we are in time pressure, we need to get closed. I see, Mikael, you have asked also a question that, which is a smart question. Inform also everyone else that a practical question: can the construction worker actually hit the 45 millimeter rafter through the 400 millimeter insulation? And I give you a quick feedback. Yes, it's a challenge. It's a difficult on such application. And we need good masters on construction site who will handle that case. But it is possible. Maybe that's the quick feedback here. I will.
Yes, and usually they have to put the line. I don't know what this is in English, but you have this colored rope, and you make a mark so that you keep your position. That's always important also to instruct the installers.
Yeah. To end this academy, then I will look. There is one more question. But we have that SWOOD and spec toolbox, which was previous discussions. And I quick grab that Oleg's question also. Are screws with 6 mm diameter available for calculation? We use mostly 45 mm by 45 mm timber pattern. Actually, it is a problem to use 8 mm screws. What is your comment, Markus, on that case? If you use only 45. I know the norm on ETA says also 40 by 60 is the minimum, so the width of the 60 should be covered.
Yeah, it should be 6 in the ETA, but only if there's for 10 mm. So it would work. There is no restriction for an 8 mm screw there according to the ETA. Okay, it should be 5 centimeters then. Yeah.
And maybe quick feedback for Oleg is that often they change the patterns to 45-70 or 75, one case, or you go with 60, but 60 have a limited lengths. So you're not able to go for maybe a thicker insulation than 150-200 mm.
Yeah, I think that's also the reason, because for the 8 mm, because of the length, and also that you don't want the screws to move too much, and there's 8 mm is better because they are more stable when you screw them in.
I'm not going to raise any feedback questions next, which actually was in the plan, but I've just informed you. Thank you for participating, everybody. June 9th, we have our next academy where Markus is here. So if you have some more questions, registrate. Hopefully we have a time to answer then also coming up questions, but then we present already a next subject and you will hear more about by end of May. From my side, thank you very much. So we have technical experts, Radoslav, who support Eastern Europe. We have engineer Tiar and me. So find the contacts here and we are ready to make you a demo when you are in trouble, come to visit, or also show our earlier tools which we have presented. So thank you very much, everybody. Thank you, Markus. And we need to prepare for another academy, which starts soon for Nordic region, so Norway, Sweden. Thank you.
Okay, thank you very much for listening and see you next time.
Thank you.
Bye-bye.
Goodbye.